So if we talk about nuclear fission, what we do is actually we bombard a nucleus with heavy mass. That is a, say suppose you are taking a uranium nucleus. Uranium has mass number of 235 U, an atomic number of 22. Now what we do is we bombard this with a neutron. I bombard this with a neutron, so it is actually given. If I am bombarding this with a neutron, instead of this arrow sign, let's give this plus sign. So when you bombard this neutron goes over here and this uranium is excited. This uranium nucleus achieves a excited state of 236 U upon 92. So now this is an excited uranium and it is unstable. And it remains in this stage for a very short amount of time. So after that, after the bombardment takes place, this excited uranium breaks down into two fragments of smaller atomic mass. And this is, one is krypton. Sorry, this is not kryptonian, it's krypton. It's 89. The mass number is 89 and the atomic number is 36. And the second one is barium. That is a release of barium. That is, this is 144 and this is 56. With a release of 3 neutrons. So if you take out the sum, this is 89 plus 144. 89 plus 144 gives you, this is 3. Then this is 9, this is 3 and this is 2. 233. Plus another 3 neutrons. So 233 plus 3 is actually equal to 236, which is this. So in a way we know that there is no loss of matter. Now 236 is actually equal to 235. That was the mass number of this uranium plus one extra neutron. So in a way the neutrons is being conserved, and this is what happens. Now this 3 neutron is released along with the release of high energy. So this is the whole process of nuclear fission. Now if you try to look at another example, say suppose sometimes what happens is instead of this, sometimes if I bombard this uranium 92, first I'll get the excited state. My excited state is 236 U upon 92, and this will further break down into 133 SB upon, this is 51, it's not upon this 51, plus 99, sorry, this is 99 NB upon 41 plus with a release of 4 neutrons. Now if you look closely, these are all reactions, and these all are capable of chain reactions. Now we have used the term chain reaction. How can this particular reaction be taken to be a chain reaction? Now say suppose in a particular container you have many different uranium elements. So you have stored up uranium. You have stored up a huge number of uranium element. Now what you can say is, if you strike one uranium with this neutron, there's a release of energy with a release of 3 extra neutrons. So this 3 extra neutron will in turn strike 3 other uranium, and this 3 individual uranium will give 3 neutrons of their own. So after 1, I have 3 neutrons, and these 3 neutrons will in turn strike another uranium. So after 2 striking of uranium, initially it was 1 neutron, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have 9 extra neutron with the release of high amount of energy. So this 9 neutron in turn will strike another 9 uranium, which in turn individually will give release to 3 neutrons. So in this way we can see that if it is not controlled, we can see the use of this particular technology in bombs, in nuclear bombs, they use this particular technology, that is to create a chain reaction so that there is a huge release of energy at a small amount of time. So this is basically the concept of nuclear fission and its uses. Now let's have a look at how can we control. If it's uncontrolled, we use this in destruction. Now say suppose if we want to control this nuclear reaction, then we do this controlled nuclear reaction in nuclear reactors. So let's have a look at nuclear reactors in our next slide.